Well, here we are after a little bit of difficulty getting my Facebook to work. The new version is slightly complicated and would not let me go live. But here we are for the next 20 minutes or so. We're going to be talking about plankton, one of the most amazing things that we have on the planet. My name is Jeff Avery. I am the owner-operator of Cape Cod Learning Tours. I'm also known as Captain Awesome. Some of you may or may not know me. We do frequently some live free programs for local folks. One of those things is a plankton pop-up lab. This year, I think we're going to be greatly toned down because of everything that's going on. And I decided that since some of you have some little ones that are home from school, that maybe it would be worth trying to do something every day for a half hour or so. Understand, I am not a technically savvy individual. So you're going to get kind of crude today. You're going to get pieces of paper. I'm not sure that you can see those. Somebody tell me if those are backwards or not. Can you actually see the words? Are they forwards for you? Because yesterday, everything was backwards, and I felt a little bit like a fool. So I'm going to try to avoid that. So let's hop right in. So plankton, right? So everybody kind of knows what plankton is. Little ones are generally most familiar with that lovely gentleman from SpongeBob SquarePants. Believe it or not, the gentleman who wrote SpongeBob SquarePants used everything in SpongeBob kind of has a factual thing. For instance, Patrick, incredibly lovable character. He's a sea star. One of the things about Patrick is that he's not the brightest individual down there in Bikini Bottom. There's an actual reason for that. Sea stars in reality have the ability to move, to reproduce, to eat. They can sense light and shadow. They have a nervous system, but they don't have a central part of that nervous system. They don't have a brain, okay? Don't have a brain. So that's why Patrick in the show is so dumb, because he doesn't have an actual brain. And one of the most loved characters there, of course, is Plankton. I will get that Krabby Patty recipe. And he's a copepod. And he is based on a real live animal. And we'll talk about that in just a second. So I wanted to show you a couple of quick examples. There's lots of online resources that you can find. This couple of pages I'm going to show you are some quick identification of the different types of plankton that you can find. So you look up here, there's kingdom protozoa. Those are some of the tiniest little animals on the planet, right? Then we've got kingdom chromista, which are diatoms and foraminiferae. And then we get into the kingdom Animalia. I'm doing my best here, folks. I'm sorry if it's hard to see, right? Kingdom Animalia. So you'll see a lot of those Medusa-type little animals, right? They all kind of look like jellies at the top, but some of those are actually small snails. Periwinkles start just like this one right here, right? And then we've got some comb jellies, and then we've got some nematodes and things like that. And we've also got echinoderms. See this guy right here? I'm going to show you a picture that I took a while back in one of my plankton samples that looks exactly like that. And that right there can turn into any number of different kinds of animals, okay? So I've got 3 very quick pages of stuff. This is actually plankton of southern Britain, but you'll see that it's all very similar to what we have here. You'll actually probably recognize a decapod, which is a type of crab, and there's shrimp and all sorts of things. So, Lindsay, there's 2 main types of plankton. We're going to get to that right now. The 2 main types of plankton are zooplankton, which are animal plankton. ZOO, like in a zoo, those are animal plankton. Now, almost every invertebrate in the ocean starts in the planktonic column. Sea stars, sea cucumbers, barnacles, sea anemones, jellyfish, all those things, when they hatch out of an egg, they're microscopic. You may have eaten a 1.5 or 2 pound lobster. When those animals hatch, they are part of the plankton column. So those are zooplankton. I have some examples here. Some of them are fully grown, some of them are larval. There's also phytoplankton. Now, phytoplankton are vitally important to the earth. Phytoplankton, Jamie, yes, I will post a bunch of these pictures as well as some resources on the Facebook page and on my website a little bit later on as well. So here's why phytoplankton is important. I want everybody that's watching right now to take a deep breath. What's the most important ingredient in that breath you just took? Oxygen. We all know that we need oxygen to survive. We go 3 minutes without oxygen, we might live, but we'll probably suffer some brain damage, right? And because of the way we were raised and because of the way that the textbooks are all written, 99% of the people that I talk to, even when we're talking about plankton, Jack, no, I cannot see you. I'm sorry. I'm working on some sort of program where I'll be able to see you and be more interactive, but I am watching the comments as they come up and down the page. So when you were in school, you saw a diagram about photosynthesis. And that photosynthesis probably had a close-up of a leaf. And that leaf was attached to a tree. And you know that what leaves on a tree do is take in carbon dioxide and then give off oxygen. So your entire knowledge about photosynthesis is on land-based plants. But if you do the math and you think about how much of the planet is actually covered with plants, right? Minus the deserts, minus the ice caps, minus the high altitude mountains, only about 15% of the entire planet is covered with plants, land-based plants. However, 65 to 70% of the planet is covered with water. And every single inch of that water, down to a depth of 70 feet, has phytoplankton. And believe it or not, 80 to 85% of the oxygen that you breathe comes from phytoplankton in the ocean. The ocean stirs up, the waves actions, oxygen comes off the surface, carbon dioxide goes in, the phytoplankton convert it, they turn it into oxygen, and off we go. And that's happening 24 hours a day across the great oceans of the world. That's why taking care of the ocean is so important. Now, we're going to have just one very brief discussion about why the climate change and the warming of the ocean is so important. Now, you have to understand that I'm a naturalist. That's an ist with the least amount of education. So I can't really dial into the chemistry of why a warmer ocean is more acidic, but it is. So a lot of these diatoms and creatures that create the oxygen are covered with a silica shell. Now, if you've ever taken and put a little vinegar on an egg and let it sit for a day or two, you'll notice that this eggshell gets soft. The same thing happens with the silica casing of the phytoplankton. And if the phytoplankton don't have the silica casing, they can't survive. So as the oceans warm a little bit, they become more acidic. Now, one of the byproducts we've seen of that is, obviously, we've seen coral reef bleaching and issues like that. But even more important is that we've had already a mass die-off of phytoplankton. The amount of phytoplankton in the ocean has been reduced by about 40% in the last 25 years. This is the fundamental engine that creates the oxygen that we breathe. This is why it should not be politicized. It shouldn't be a thing that we're arguing about. We should be taking every step that we can to try to solve the problem as quickly as possible, because we literally will not have any oxygen to breathe if we don't solve the problem, okay? And then another very quick thing, a lot of people don't understand, when we see plastic, we're talking about plastic, like we see plastic water bottles or plastic bags and things like that. Well, this is a picture that was in National Geographic. And this is the size that the plastic ends up in the ocean. Some of it even smaller than that. That's a larval fish caught in a plankton toe. And those pieces of plastic there are only a micron or so across. That's a rather tiny piece of plastic. What's happening is that the plankton are actually scooping them up. They're not the brightest thing in the world. And then they're ingesting the plastic. The plastic does not get digested. And then this tilefish eats that little piece of eats the plankton with the plastic, and so on and so forth, up all the way to whales and basking sharks. And we know that a lot of these plastics are not healthy. They create blockages. They give off bad stuff. So we really do have to reduce the amount of plastics that we use. I would highly recommend that you just drink the water out of your tap. It's actually probably cleaner than the water that's in a plastic bottle. Okay, so there's my little preachiness right now. So how do we know about plankton? We have a way to sample plankton, of getting plankton. You'll see in the bottom here, this is a plankton net. So it is a fine mesh net with a little cup on the end. So to catch phytoplankton, you've got to have a mesh on that net that's less than a micron generally. I catch a lot of stuff. I do plankton pop-ups during the summer. Keep an eye out for those. And we drag this through the water, or we put it in the current, and we let the water flow through. Now, if we know the diameter of the net and we know how fast the current is, we can determine how much water flowed through the net. Now, the way that we measure the phytoplankton is we know that phytoplankton has chlorophyll in it. So when I say that we've had a 40% reduction in phytoplankton, what I really mean is a 40% reduction in chlorophyll. The way they do that is they collect all the material that's down here on the end. They put it through a vacuum and put it on a little paper disc, and then they have a sensor that can measure the amount of chlorophyll in the sample. When they're looking at the chlorophyll in the sample, they can then measure it, and they have a good idea. They can go back to the same locations, do the same tow at the same speed, and compare them and figure out how much chlorophyll is in the water. So when we do a plankton tow, sometimes we do them in Scusset Pier, we do them down in Chatham, we'll do the same thing, and we'll look under the microscopes, and I'll show you some actual photographs that I've taken on my items, and you'll see that it's just as amazing as what you see here. This is something you can partake of locally. We have a lot of resources locally. There's me, there's the Museum of Natural History, there's the National Aquarium down in Woods Hole, all very amazing stuff, okay? So we know that plankton comes from the Greek, meaning drifter, okay? So plankton can move. If you watch some videos that I have, the plankton move and swim and do that kind of stuff. But what they do is they drift on the current because they can't fight the current. They're swimming and they're moving, but they're actually being carried along by the current. One of the common misnomers is that these plankton are very tiny and microscopic, and not all plankton are microscopic. In fact, a very common type of plankton that many of you have seen are ctenophores, or jellyfish. This is a moon jelly. We have these very commonly in the waters around here. In Bass River, when I was a kid, there used to be bucket loads of them, and they're still around. Also, hold on, sorry. We've got other larger jellyfish, like a sea nettle, or a Portuguese man-o'-war, or in the waters around here, sometimes you'll see a lion's mane jellyfish. This is the red jellyfish. Now, they have a pretty fierce sting. In the Arctic waters where it's very cold and they're slow growing, they can get to be 10 feet across on the bell, with tentacles up to 100 feet long. And that is still considered plankton because the current moves it around. Miss Lindsay, I am a naturalist and I own Cape Cod Learning Tours. My primary job is a chef. So one of the good things is that I get to sometimes catch some stuff that I get to eat. Isn't that kind of nifty? So phytoplankton, one of the more important types of animals, okay? So this is a picture that I took. This is a saltwater version of a radiola. And all those little green dots are specks of chlorophyll. So this is a tiny, tiny little plant that drifts around in the ocean, just producing. And we'll get to the zooplankton next because the zooplankton eat these, okay? This is the basis. This is the basis of the entire food chain of the planet, the entire planet, okay? Everything starts here, okay? This is a sample that I took down in Chatham in the marsh, and there's a number of different things here, but they're mostly diatoms. See some diatom here. All these long rods are diatoms, and the clear that you see is the silica casing that is protecting that chlorophyll that's inside. That kind of clear spot is the silica casing that we talked about when the water gets warm and a little more acidic. That's what happens. This is literally a drop of water. It's not even a full drop. It's like a portion of a drop of water. This is one of the more common types of phytoplankton that we have in the water around here. This is a dinoflagellate. Now, I didn't get a good picture of it all, but all along the horns of this critter are tiny little silica, and they can swim around using those little silica. These are very common. There's a number of different types, and they're really remarkable. You can identify them both by the look, but even when they're short and stumpy, they have that kind of ring around the cap there that indicates what they are. This is another diatom. Looks like a needle. Again, that glass silica shell that holds the chlorophyll in place. And this is a plant, not an animal. It can move, and it converts sunlight into energy, but not an animal. This is another type of algae. This is a little bit of algae on the back, a sheet of sea lettuce. But what I really want you to see is how well you can see the chlorophyll inside and then the silica shell. That silica shell is so important. That's that. I already did that. I already did that. This is another type of phytoplankton. Long chains like that. They get broken up and they can grow again. Each one of these little individual cups has 4 little caps inside of it. I wish that I could give you the names of all of these things. There's so much of it that I can't, but I can point you to an identification directory on the Facebook page a little later. And here's one of my favorites. Now we're looking at this, we're looking down. We're looking straight down on this little diatom chain, and it spirals down. It's a really cool diatom chain. It can break up. It'll survive. Really, really cool stuff. All different kinds of plants, millions of them. And then I think we're getting into the zooplankton. Oh, one last little diatom. That sucker is about half of a micron across with that cluster of chlorophyll in the center. This is a type of red algae. I don't get this very often. Red algae tends to be the toxic types of algae. Now, they're out there often, but they are also They don't become real harmful unless there's a bloom, and they tend to get eaten or collected by filter feeders like oysters and clams. I'm not sure what kind of algae this is, but it was a cool picture at the very least. Now we're into zooplankton. This is who Plankton on SpongeBob is modeled after. This is a copepod. This is the most abundant animal on the planet. There are a number of different species of copepods, like there are a number of different species of snakes or different species of flies. If you collected all of the copepods in the entire ocean and you put them on a great big giant scale, and then you took all just copepods, nothing else, no fish, no shrimp, no whales, just copepods, and you put them on a great big giant scale, and you took all of the animals that lived on Earth, us, dogs, cats, chickens, elephants, rhinoceri, birds, worms, everything, and put it on the other side of the scale, the copepods would outweigh every living thing on the planet. The only way that that balance could probably be tipped is if we made sure that we got my ex-mother-in-law on the scale. She's big enough that that might be a problem. Just joking. So this is a quick sample of a plankton toe that I did in the salt marsh down at the Sandwich Boardwalk. It is hard to describe just in this picture how much stuff is actually here. You can see this. This is a mussel, a larval mussel. See its little filter feeders sticking out there. Then we've got some shrimp. That's a clam. And there are lots of other things in here that are hard to show you with the picture. I'm going to put this on my Facebook page. You could take a look. There are literally, in this drop of water, about 100 different animals in about 10 different species of animals at least. I could literally do that for hours down there collecting and looking. Here's an example of a larval clam. There's that dinoflagellate I was telling you about before. It's a larval clam. It is smaller than a grain of salt. That is how tiny it is. It is hard sometimes for people to understand that that 38-inch striped bass that they're having for dinner started only slightly larger than this. This is a sea louse. It's a fully grown animal. You can see the mouth parts on the front that are round with the little fibers. They literally just spin those fibers and inhale anything that gets close enough, including those microscopic bits of plastic. This is about 1,000 times bigger than those phytoplankton diatoms I showed you before. Here's another copepod. This is a picture that I took. Again, one eye, distinct one eye, 2 long antennae, and then a little part back here. Sometimes you'll see them with big bunches of eggs back there. And they have a predator. I don't have a good picture of it right now, but there's a predator called an arrowworm. It's just literally a long, skinny, clear planktonic worm that eats as many of these as it can. Oh, wrong direction, sorry. So this is a really alien looking piece of zooplankton. And this can become one of about 4 or 5 creatures that we have in the waters around Cape Cod. This is an echinoderm larva. Echinoderm means spiny skin. We have a couple of different animals in the Cape Cod waters that are echinoderms. Sea stars, sea urchins, both purple and green, sea sand dollars, and sea cucumbers. Those are all echinoderms, and they all start looking like this. I think it looks kind of like Sputnik. I think it's really cool. I love when I find one of these. I don't find them super often, and I thought I got a pretty good picture out of that one. Again, this is tiny, 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 so small. I have no idea what this is. Now, it has tentacles, so I'm assuming that it's going to turn into a jellyfish or a sea anemone or some type of zoan, but I don't know. And that's one of the things that I love most about doing this. Lots of times I find stuff, I have no idea what it is, and then I go looking to see if I can find. I actually have a good friend who works over at the National Marine Fisheries. I annoy her quite a bit, but I'm going to take this picture over to her later and see if she can tell me what it is, and I'll guarantee you that within a second she'll be able to tell me. And this, how many of you love to eat lobster? This is a larval lobster, or crab, or shrimp. I'm not sure, but they all basically start looking like this. They go through a number of different stages. So you can see how large his eyes are, right? You can see the tail up here. On a crab, that'll end up curling underneath and making the disc of a crab. The lobster, it will stay extended. I do catch quite a few of these. What happens is the lobsters all release their eggs all at once, and so all of a sudden the whole area will be flooded with larval lobster. The tip of a bryozoan. Some of you may have seen some little flowery looking animals on the docks locally. This is what that is. It's actually a colonial animal, and it's a really amazing creature. And we're back to the beginning. So that's kind of the basics. Quick overview on zooplankton, phytoplankton. I'll go back to my Facebook page. I'll put some information on there for links. I'll put some of the videos that I've taken. And I think it's really cool. I'm glad that you guys joined me. Again, I'll probably try to get it. If it's not raining tomorrow, if the weather's good, then I will definitely go outside. I appreciate you being here. Tell your friends about us, and we'll see you soon. Thanks.